Hi there. We're going to do derivatives in the general case of this little function right here in yellow, and we're going to evaluate it at two different x values when we're done. So what we're going to do is we're going to do the derivative formula, which I'll put over here in blue, and that is of course the limit as h goes to 0 f of x plus h minus f of x over h. Alright, so there's the derivative formula, and this is probably going to be ultra nasty, but we're just going to go right at it like a bunch of champions. So here's our function, and we're going to plug in x plus h in for x squared. So let's see. I'm going to write really small and try to fit this all in one thing here. So that's going to be 1 over x plus h squared minus f of x. So f of x is that, so we have 1 over x squared on the bottom, and that's all over h. And so begins the simplifying process. So what we're going to do is probably at this point what I would want to do is leave. I'm kind of on the fence on this one. I kind of want to. Yeah, let's go ahead and break that down. It's okay not to know, because a lot of times that's a good thing to look at. Because you could get into a problem and get in a jam because you didn't simplify it, or get in a jam because you do simplify it. So sometimes you want to FOIL this right out, and sometimes you don't. So that's going to be x squared plus 2 hx or xh. I'm going to back up. I usually do xh at that point, so I'm going to be consistent, plus h squared. So all of that is going to go underneath here. And I'm probably going to regret doing that, but it will probably lead to some good discussion. So it's going to be 1 over x squared plus 2xh plus h squared minus 1 over x squared all over h. Okay, so instead of getting smaller, this is getting bigger, and that's never good, but that's okay. All right, at this point, we are going to have to deal with this common denominator issue. So, just to review, if we had two fractions and they were, say, 1 over 2 minus 1 over 3, and we knew our denominators were going to become 6's, well, I would multiply the top and bottom of this by 2 and the top and bottom of this by 3. So I want to do that same process over here, except I want to multiply this one by x squared plus 2xh plus h squared on the top and the bottom. And there it is. And then over here, I want to multiply this one by x squared on the top and bottom. Essentially multiplying each side by 1, because that's the same thing. All right. So on the next line, I'll go back to my green color. So let's make it a little bit lighter. I'm going to have x squared, and on bottom I'm going to keep these separated. X squared times x squared plus 2xh plus h squared. So there's one fraction minus, I'm going to put it in parentheses, x squared plus 2xh plus h squared all over the same denominator as this. So x squared and then x squared plus 2xh plus h squared. This is terrifying to look at, but not really that bad. As long as I keep the sign straight, this shouldn't be too awful. And that is all over h. So that's all in the numerator. So there's an h on the bottom. Now, putting this together and being super careful, because you can still miss this so easily because of this negative sign right here. You're going to change all three of those because of this negative sign. So getting a different color here, we are going to have on the next line, I'm going to put these two fractions together. So I'm going to have on the top x squared minus 2xh plus h squared. And on the bottom, I am going to have x squared times x squared plus 2xh plus h squared all over h. Okay, now this is going to simplify. I'm going to put that up here. Now the x squared and that x squared are going to cancel. So I'm going to have, if it's, let's see, I think I can do this. So negative 2xh plus h squared all over x squared plus 2xh plus h squared all over h. Okay, we got one little issue that happened there. So I'm going to get my eraser, and that sign right there, a second, a little bit smaller, that sign right there should be negative. So it should be negative h. Alright, so our next move, since we're dividing this whole thing by h, that's the same as multiplying this whole thing by 1 over h. So if I take this top, and actually I don't even need to factor out an h. I mean, I could if I wanted, but let me show you how to do it without doing that. So let's say I just keep that there, and that's over x squared, I think we're almost done with this, plus h squared. And I'm going to multiply that by 1 over h. Basically, I can take, I mean, I could factor this into, I'll tell you what, I might as well show you. It would be h times negative 2x minus h. So it would turn into that. So this h would cancel that h. So then this would be a 1 down here. So this now will turn into one big fraction. And I think we can just go ahead and plug in 0 for the h's. But this is going to be negative 2x minus h over x squared x times x squared plus 2x plus h squared. Okay? Now at this point, I can get away with taking the limit as h goes to 0 without making this thing become undefined. So if I put in 0 here, that's going to be negative 2x. Okay. What did I do? There should be an h right there. Okay. So that h would go away if we put a 0 here. Let me make that in green. So this would become a 0. This would become a 0. And this would become a 0 right there. I am so glad I didn't just forget that. Now, so this would be x squared times x squared. That whole term would drop out, plus 0 squared would drop out. So it's just x squared times x squared. And that would be negative 2x over x to the 4th. All right. Now, what this does, doing it in the general case, I picked the hardest example here, but this allows us to do two problems in one shot now, because I can just plug in 2 in for these x's and figure out what the derivative at that specific point is, which is slope of the tangent line at that point. So if I do this in like some weird color like white, and it would be negative 2 times 2. So let's make a note. At x equals 2, this would be negative 2 times 2 over 2 squared times 2 squared, which is negative 4 over 4 times 4, which is 16. And so that would become negative 1/4. Then if we did it at x equals -1 of this right here, that's what we're plugging it into. This would be -2 times -1 over -1 squared. Notice I put that in parentheses there. Times -1 squared, which would be 2 over 1 times 1, which is 1, and that would become 2. So you can see that by knowing... Well, let's look at the answers here. First of all, this green thing, if I asked you to just find the derivative of this function, that would be the answer. But if I asked you to evaluate the derivative or find the slope of the tangent line at a specific point of this function, it would be these two white circled answers here. Well, actually that one. So there's your crash course on derivatives in the general case. Have a good one.